Hello everyone. In today's video, we are implementing Keras model on our data that we have of diabetes. So you can download this data from Kaggle. Here is a link. You can download this data from this link here. Just enter this link into your browser, and you will be switched to this website. Here you can find this diabetes.csv file and just download this file into your system. After downloading, just have a look at this code. So here we have um, Keras model on which we will train our data and then we will predict the value. So here today I am using sequential model and at the backend I am using Tensorflow. So here I am using pandas for accessing our CSV, that is diabetes.csv. Okay, and to access this CSV we are using pandas.readCSV. So after this read CSV, it returns us a data frame. So we save it in dataset variable here, and then we are printing the dataset head to check that the CSV we access the CSV correctly or not. So after accessing the CSV, we then check that our data is there any null value in our data or not. So if there is any null value, then we have to pre-process our data. But as you can see here, we don't have any null value. It means our data is already pre-processed, and now we have to apply our model on the data set. So before we apply our model on our data set, we divide our data set into two parts. The first part contains the features and the second part will contain the label. So feature are those columns in our data set on which we will predict the outcome, and outcome is our label. So here X is defining features and Y defining labels. Also, I want you to know, here you can see the first column represents that we are selecting all the rows in our data set, and the second one it means that we are selecting column up to 8. So when you mention column 8, it means you are selecting up to 8. 8 column is not included in your data set. Then we will implement a model, that is sequential model. So here you can see we import the sequential model above using keras.model. Then we add layer to our model. So to add layer to your model, we will use dot add function in model, and the model contains the sequential. Here you can see we have a model variable which is assigned to a sequential model here. So to add the layers, you just have to mention model.add, and the layer is added to your model. Here we are using dense layer. So in this model we have three, as you can see we have three layers, and all the three layers are dense layer. Then we have some parameters in our function. So yeah, so we have here you can see we have some parameters in our function. So the first parameter is the number of neurons you want in your layer. So in first layer here we have 12 neurons, the second layer we have 8, and the third layer we have 1 neuron. Then we have to mention the input dimension. Input dimension means how many input column you have. So as you can see we have 8 input columns, so we are defining 8 as our dimension. Then we have an activation function. So for first layer we are assigning relu activation function. Then for second we have again relu, and the third one is sigmoidal function. So what activation function is, just have a look at this diagram here. So as you can see, this is our sigmoidal function. So why we use activation function? The main reason behind it is that it normalizes our data. So as you can see, whatever the value of y from minus infinite to plus infinite, we are getting a normalization value between 0 to 1, so that our model will predict that whether a person is having diabetes or not. So here you can see that our y value lie between 0 to 1, and the formula behind this sigmoidal graph is 1 upon 1 plus e to the power minus x. So using this formula, we will normalize our values. So if we have values that are above 1 or below 0, we use this formula to normalize the value, and we will get a value between 0 to 1. So this is our sigmoidal function, which is known as activation function. So here we are using sigmoidal function in our last layer. So this is what activation means here. Then we will compile our, so here we define all the layers of our sequential model, and now we will implement, we will compile our model. So to compile it, you have to pass the some parameters, and here you have to compile, just assign model.compile. So we here have a loss of binary cross entropy. Optimize, we are using Adam, and metrics we are having accuracy as a metric. Okay. So then after compiling this model, you have a trained model. You have a model, and now we will train this model using model.fit. So as you can see, we are passing some variables here. The first one is the x value, that is our feature. Then the second one is the label, our outcome value. The third one is the epochs, that are basically the iteration we want, and this is the batch size. So after executing this script, you will see that your model start learning by itself. So first epoch, here you can see we are getting a loss of 3.7 and accuracy of 59. So which is not good. Then in the second iteration, you see we are getting a loss of 0.9 and with accuracy of 59. Okay. Then later on, when this model keeps on executing and the iteration keeps on going, then you can see later on the execution in your model, you can, as you can see here, we have a loss of 0.49 and the accuracy of 75%. So this model keeps on learning by itself. That's why we use neural networks. So as you can see, on our 150th iteration, we are getting a loss of 0.47 and accuracy of 76. Then to evaluate your model, all you have to do is to define model.evaluate here with the parameters that are features and labels, and then just print the score using model.matrix name 1. So in the matrix name you have here accuracy. So just print it out, and you can see we are getting an accuracy of 79.56, which is a very good accuracy. And to predict the values, you have to use model.predict function here. And in this predict function, you will send the feature value, and then it will return the label of your the prediction value, that is your outcome. So as you can see here, we have a prediction value here, and we are rounding this value. So what we get is we get a value between 0 to 1. Then we will round that value so that we either we get 0 and 1. So after rounding off this value, we will get these values as our prediction. So here 1 defines that the person is having diabetes, and the 0 defines that a person is not having diabetes. So this is all in our model today. So this is all in today's tutorial. Hope you gain some knowledge from this. See you in next tutorial. Thank you.